Hello guys, this is the complete geometry part 1 which is very useful for Hstr, Gpstr, TET, CET and all other upcoming examination, and this is even very useful for any competitive examinations. So in today's class we will see very basic concepts of a geometry. In very first class, we are going to see some basic geometrical ideas which are very helpful for our upcoming classes. Before that, please subscribe the channel. Basic geometrical ideas include a point, line, ray, and other fundamental elements of geometry. So first we will see what is the meaning of point. A point represents a location or a position and it is a dimensionless. This is very important. It can be denoted by a single capital letter. See here we have a dots. So this, if I want to denote this dot, I will write this with any capital letter dot A. If I want to denote this, I will write a dot C. If I want to denote this dot, I will take a dot E. Means to denote a point, we have to use a capital letter. Then line segment. A line segments are defined as the shortest distance between 2 points. A line segment joining a point L and M is denoted by. If this is a point L and this is a point M, then the shortest distance between L and N is nothing but a straight line and it is a line segment. See here, if this is L and this is M. If I want to travel from L to M, I will choose this path. But this is not a line or a straight line, or even this is not a shortest distance. If I choose this path, even though this is not a shortest distance, the shortest distance between the 2 points is nothing but a straight line, and that is a line segment. One more thing, line segment has a fixed measurement, means LM, maybe it's a 7 centimeter, maybe it's of 5 centimeter, but it has a fixed length or fixed value. That line we call it as a segment and it is denoted by, see here, LM is of fixed length. LM is equal to 7 centimeter. Then I will denote this LM with this line. A distance between two end points of a line segment is, that is a length of line segment, just we have seen here. Then a line. A line is made up of indefinite number of points that extends indefinitely in both direction. A line containing L and M is denoted by. Again, I will take a same. See here, this is a point L and this is a point M. But this L is also increasing in backward direction and this M is also goes on increasing in forward direction. Means that is the main difference between line and a line segment. Line segment is of fixed length. 7 centimeter means it's 7 centimeter. It will not increase to 8 or decrease to 6. But LM here at both ends we have arrow marks. It indicates that line is increasing in both the direction. Hence this has a no fixed length. So LM line can be denoted by this arrow mark. If you want to denote a line, then LM line is denoted like this. If you are denoting a segment, then LM is denoted like this. No arrow mark on both ends. That is the main difference. Then array. Array is made up of indefinite number of points that extends indefinitely in only one direction. Arrays containing point L and P is denoted by. See here, if I take this point as a L and this point as P, in between we have many points, but I have only 2 points to express this array, L and P. L is not increasing in backward direction, but our P is goes on increasing in forward direction. Means a ray indicates that it will increase only in one direction. So how to denote this ray? So L is not increasing, so I will keep this end as it is. P is goes on increases, so I will increase this P. LP, this is called a ray LP. In first LM line segment is denoted like this. LM line is denoted like this, and LM ray is denoted like this. That is the main difference between a line segment, line, and a ray. One more very simple example to remember about ray. If I take a torch, see here, the rays are emitting out from this torch are having a starting point, but it's not having an ending point, means it's increasing in forward direction. So this line is not increasing in backward direction, means it has a starting point but it has a not ending point. This indicates a ray. So this is very simple example to keep or to understand the difference between ray and line. Next we have a plane. A plane is said to be a very thin flat surface that does not have any thickness or a limitless. A minimum of 3 points are required to represent a line plane. If I have only 2 points, then I can represent a line, line segment, or an array. But to represent a plane, I require minimum 3 points. If I take this one, then this is a triangular plane. If I take 4 points, then it is a quadrilateral plane. Like this, a plane is a having a negligible thickness, means like it's a, I can take an example of paper where thickness is negligible, so you can understand what is the meaning of plane. Then curve. A curve can be defined as figure that flows smoothly without a break. Curves do not intersect themselves are called as simple curves. So here, if I take this one, this will as a straight line, but curve can be defined as with smooth without break. So this can be taken as curve, this can taken as curve, this can taken as curve, any figure. And if it not intersects, see, if this intersects, then it's not a simple curve. If this is not intersecting, then it's a simple curve. Then we have a open and closed curves. This is very useful for your examination. The endpoints of open curve do not meet. See here. This is a initial point and this is a end point. For open curve, the initial point and end point will not meet each other. So that curve is called as open curve. So this is an example of open curve. Then, while the endpoints of closed curve join to enclose an area. See, if I want to enter in this figure, I can enter from this point. But if I want to enter into this figure, I can't able to enter here because all the boundaries are closed. This is nothing but a closed curve, and starting point is here, then end point again comes here. So in open curve, starting point and ending points are different. In closed curve, starting point and ending point is same. Whenever we come to the closed area, then we have a 3 points. This is a boundary, this is exterior area, and this is interior area. If I have a point A here, point B here, and point C here, then in examination they may ask about point A is an interior point B is an exterior point, and point C lies on a boundary. Then simple curve. Already we have discussed this. A simple curve that doesn't intersect or cross itself is called as simple curve. Then we have an angle. Angle is made up of two rays starting from a one common point. So this is one ray and this is another ray, but both are starting from a single initial point and where a angle is formed. The two rays join at a common point is called as angle. Here we get angle. So based upon again types of angles are there, but just here we are discussing very basic concepts. So I will take definitions only. Polygon, simple closed curves made up of only line segments is called polygon. See here, This is also a line segment, but this is a smooth curve and this is not a polygon. Here, I must say that we must have a line. So, this is a triangle which is a closed curve and it is closed by three line segments. So, what polygon says? Polygon must have a n number of points connected each other with a straight lines or a line segments, and it must be a closed figure. Here also these points are connected by line segments and this is a closed figure. So all these are the examples of polygon. Next, circle. This is very useful for your examination. A circle is a simple closed curve formed by a points moving at the same distance from a fixed point. If I take this fixed point as O, I will have n number of points which are at an equal distance from the central point. And this distance is nothing but a radius of a circle. We know that. A circle is formed by points moving at the same distance from a fixed point, and that fixed point is nothing but origin. A circle is also simple closed curve. So this is very important. Circle is also a closed curve and it is a simple closed curve because the curves are not intersecting here. However, it does not have any sides or angles, and air is a part of the circumference of a circle. Next, a chord. This word is very important. What is chord? Is a line segment joining two points that lie on a circle. If this is a circle and this is a center O, you can select any two points on the circumference of a circle and you connect them. If I connect these two points L and M, now this M is nothing but a chord. And because of this chord, I can divide my whole circle into two parts. This is upper part is bigger half circle and this is a smaller half circle. A chord is passing through the center of a circle is a diameter. See here, if I take this chord little bit upper side, when it crosses the origin means when it passes through the origin it will become a diameter. The biggest chord of a circle is nothing but diameter. A diameter is, see here, it is the longest chord of a circle. The diameter of a circle divides a circle into two halves. Each half is called as semicircle. A line segment that joins the center of a circle and a point on the circle is nothing but a radius of circle. This is very basic concept. Then the radius of a circle is half of the diameter. See here, this is very important. The radius of a circle is half of diameter or diameter is a double of radius of circle. A part of circle that is enclosed by two radii is called as sector. See here, if this is a circle, this is the center of a circle. I have one radius here, one more radius here. These two radius are of equal length and in between area is enclosed. That area is called as sector. See here, the area enclosed between two radii of a circle and this is a arc is called as sector. In this, we have to, okay, in this we have to denote all the parts of circle. See here, this is a center of circle O. OP is nothing but OP is a radius of circle. Then I will take this point as Q. Then see here, O is a center of circle. OP is a radius of circle. Then PQ. All these are having line segments. So I will write this as a PQ. PQ is a diameter of circle. Now I can say that PQ is equal to double of OP. This is very useful for your examination. Then I will take any two points from a circumference. So this is a point L, this is point M. I will denote this by a straight line. Then I have a one arc here and This LM, which is a curved path, is called as arc, and this LM, which is having a straight line, that is called as chord. You must know about what is the difference between arc and chord. Arc is a curved surface and chord is a straight line which connects the 2 points on the circumference of a circle. So LM is a chord. Then we will come to sector. So this is one arc, this is one radius, this is one more radius. The area enclosed between two radii and one arc is called as sector. So these are some important terms which comes under circle. Next we have a quadrilateral. If any polygon having a four line segments is called as quadrilateral. A quadrilateral has a four vertices, where these are four vertices, four sides. If A, B, C, D are the four vertices, then four sides AB, BC, CD, and DA or AD. These are four sides and four angles. So this is one angle, second angle, third angle, and fourth angle. And having common vertex are called as adjacent sides. If A is a common for side AB and DA, then AB and DA are called as adjacent sides. So like this, we have other examples of quadrilaterals also. Then next we have a triangle. A polygon is made up of three line segments is called as triangle. A triangle has a three vertices, three sides and three angles. Where are the three vertices are? The three vertices are these. I will denote it as a P, Q and R. Then it has a three sides, side PQ, side PR and side QR. And it has a three angles, angle PQR, angle QPR and angle QRP. Next, whole summary of the class is term, dimension, graphic and symbol. So point has a dimension, zero dimension. It has a graphic point. It can be denoted by point A. Line segment. It has only one dimension, that is a length. AB has a fixed length, hence it is denoted by line segment AB. Then ray. It's also having only one dimension, that is length, but it is increasing in one direction. So I will take ray AB. Line. Again, it has only one dimension, that is length, but it's increasing in both the directions. So I will denote line AB like this. Then this is an example of plane. It has a two-dimensional, one is length, another one is breadth. And to explain a plane, we require two dimensions. So in today's class, we covered some basic concepts of geometry. In next class, we will discuss another higher concepts of a geometry that is those are very useful for your examinations. Thank you so much. Please subscribe.